All right, solving systems of linear equations. Now we're in 3 variables. We're going to start out with the substitution method, just like we did with 2 equations with 2 unknowns. Now the graph is going to look like, in 2 equations, 2 unknowns, there are going to be 2 lines crossing each other. This is actually 3-dimensional, so this is actually like 2 pieces of paper, or 3 pieces of paper, all intersecting at a single point. We're going to start with our first example using the substitution method. We're going to have x equals 4, 2x plus y equals 3, and 3x plus 5y plus 6z is going to equal -1. And I'm going to label these equation A, B, and C. Just so we can keep track of them. I'm going to note that I already know what x is. I'm trying to now get y and z. So I'm going to take when x equals 4 and put it into equation B. And I'm going to end up with 2x, or 2. We'll plug in, equation A into equation B. So we're going to end up with 2. And I'm going to replace the x in equation B with a 4. Now, I have a single equation with a single unknown. And now I'm going to solve for y. I'm going to start out multiplying 2 times 4 to give me 8, plus y equals 3. And then I'm going to subtract the 8, giving me that y is equal to -5. I now know that x is equal to 4 from above, and y is equal to -5. I'm now going to plug in x equals 4 and y equals -5 into the third equation, equation C. So I'm going to end up with 3 times 4 plus 5 times -5 plus 6z equals -1. And now I have a single equation with a single unknown. 3 times 4 is 12. 5 times -5 gives me -25 plus 6z equals -1. Combining my like terms, I'm going to get -13 plus 6z equals -1. And I'm just going to solve this nice, easy, linear equation. I'm going to add 13 to both sides. 6z equals 12, giving me that z is equal to 2. So my answer, I'm going to write it as an ordered pair, is actually going to be x comma y comma z, which is going to be 4 comma -5 comma 1. 2, pardon me. Next, we're going to use the elimination method. This one's much more practical. And the steps that we're going to use, step number 1, is we need to decide which variable you're going to eliminate. Now, you're given a choice of 3 of them, and what we're going to want to do with our examples is we're going to want to decide which of the 3 is going to be the easiest to eliminate. So, for example, if we just wanted to eliminate the z's, and it was easy to eliminate the z's, then we would have our next step, which is step 2. You're going to create 2 two equations with the same two unknowns. Now they need to be the same two unknowns so that you can drop it down to a 2x2 system, it's called. Now our third step is going to take us back to our previous semester and actually earlier lecture, where you now have a 2x2 system, or two equations with two unknowns, and you're going to solve the system. Usually when we're doing this method, the easiest way to solve this 2x2 system is using the elimination method. We're going to take our time with these problems because these can get quite messy. This third step, we're putting down the elimination method. However, if the substitution method presents itself, that's always a nice one as well. Whatever works best. So here's our first example. We're going to take our time with these. These take a little bit of time to even write out. So 3x plus 2y plus z equals 4. That's our equation A, we'll call it. Next one is 2x minus 3y plus 2z equals negative 7. We'll call this our equation B. And lastly, x plus 4y minus z equals 10. And that'll be our equation C. Now, as we look at this, we want to figure out which letter is the easiest to eliminate. So our step one says decide which variable we will eliminate. I'm going to notice that the letter Z is going to be very easy to eliminate if I take equation A and add it to equation C. You see I have the plus Z and the minus Z, and they will eliminate very, very nicely. So when I add equation A to equation C, I'm going to have 3x plus 2y plus z equals 4 plus x plus 4y minus z equals 10. And we're going to go ahead and add everything together in this case. So I have 3x plus x is going to give me 4x. I have 2y plus 4y is going to give me 6y. Z minus z is gone, so we've eliminated the z. And then 4 plus 10 is going to give me the 14. And there's one of my two equations. Now what I'm going to do next is I now need to get rid of the z's again. In this case, we're not going to use equation A and C. We're going to use equations B and C. And I'm going to notice when I look at the z's in B, I have 2z. And the z's in C is minus z. I'm going to notice if I take equation C and multiply it by 2, that'll give me my minus 2z so that the z variables will eliminate. So I'm going to take equation C and multiply it through by 2, which is going to give me 2x plus 8y minus 2z equals 20. And I'm going to add that to equation B, which is 2x minus 3y plus 2z equals negative 7. Now, because I chose z at the beginning, I have to continue with this. And very nicely, I'm going to add these up again. And I'm going to notice 2x plus 2x is 4x. 8y minus 3y gives me plus 5y. Negative 2z plus 2z eliminates z, which is exactly what I was trying to do. And 20 minus 7 is 13. All right, we now have two equations with two unknowns. My first one is 4x plus 6y equals 14. And I have 4x plus 5y equals 13. And I'm going to notice I now have two equations with two unknowns. And we've done these before. This is not new. I'm going to use this is step 2. So we've just created our two equations with two unknowns, the same two unknowns. And now we're going to move on to step 3, and we're going to solve this system. And we're going to try using the elimination method. I'm going to notice that if I take the first equation and subtract the second equation, then I will be able to eliminate the x variables. Let's call the first equation d, and the second equation e. So I'm actually going to go equation d minus equation e. And that hopefully is going to eliminate my x values. Now I've got to be careful with the subtraction. I have to almost distribute a negative is what it's going to look like. So I have 4x minus 4x, the x's are gone. 6y minus 5y gives me just y. So it's like I'm distributing that negative to that 5y. Same here. 14 minus 13 is 1. And very nicely, we now have that y is equal to 1. I'm going to take y equals 1, and I'm going to go ahead and put it into equation d. So I'm going to have 4. Yep, so we're going to plug y equals 1 into equation d. So I'm going to have 4x plus 6 parentheses 1 equals 14. And now I have one equation with one unknown. These are easy to solve. Subtract the 6. We get 4x equals 8, which means x equals 2. All right, I now have 2 of my 3 unknowns. I'm now going to take x equals 2 and y equals 1, and I'm going to plug it in all the way at the top. I'm going to plug it into equation A, all the way at the beginning. It actually doesn't matter which ones you plug it into, but we'll plug it into A. So we're going to have 3 times 2 plus 2 times 1 plus z equals 4. And once again, I have one equation with one unknown, and I can now solve for z. I get 6 plus 2 plus z equals 4, combining my like terms. 8 plus z equals 4. Subtracting the 8, I get that z is equal to negative 4. And my ordered triple, or my point, is 2, 1, negative 4. And that is my final answer.